Okay, this question is find the coordinates. So we need to find the coordinates and the nature of each of the stationary points. So each of suggests that there's more than one. On the curve 3x cubed plus 9x squared plus 4. You must show all your working. So I always start this in the same way. Y equals 3x cubed plus 9x squared plus 4. In order to find my stationary points, I need my dy by dx. So that's the next thing I write down, which is going to be 3 lots of the derivative of x cubed. So it's going to be 3 lots of 3x squared, which is going to be 9x squared. Then the derivative of 9x squared is going to be 9 lots of the derivative of x squared, which is 2x. So that's going to be 18x. And the plus 4 is a constant that differentiates to nothing. Then I have my second derivative, so d2y by dx squared. And I will need this for the nature of the stationary points. So I'm going to differentiate again. So 9x squared, as we've just seen up here, differentiates to 18x. And 18x will differentiate to 18. So these are my key bits of information for me to use throughout this question. So we want to find the coordinates and the nature. So the first thing I need to say is that stationary points, so this curve is stationary when dy by dx is 0. That means when the gradient isn't positive or negative, so that means that the graph isn't moving upwards or downwards, it's just staying where it is. So I have an expression for dy by dx. There it is. So I make that substitution. 9x squared plus 18x equals 0. Now, it'd probably be easier here if I divide everything through by 9. So x plus 2x equals 0. And this is a simple factorising rather than a quadratic factorising because there's no plus constant on the end. So this just becomes x times x plus 2 is 0. So either from here x is 0, or from here x plus 2 is 0, so x is negative 2. We have two values for x. Now, that's the x ordinate, not the coordinates. So I need to find out the y values. So when x is 0, my y is going to be 3 lots of 0 cubed plus 9 lots of 0 squared plus 4. Okay, all I've done is I've substituted into this. And that will give me 0, 0, 4. So y equals 4. So we have one stationary point is at 0, 4. The other stationary point is when x is equal to negative 2. So my y is 3 lots of negative 2 cubed plus 9 lots of negative 2 squared plus 4. So that's 3 lots of negative 2 cubed plus 9 lots of negative 2 squared plus 4. That's 16. Okay, so my other stationary point is at negative 2, 16. Okay, so that is the coordinates of the stationary points. Now I need to look at the nature. Now, really speaking, I've got a good idea about the nature of these anyway, because this is a positive quadratic, positive cubic graph, and a positive cubic graph will start low and end high. So the first point, as I come across here, the first point I come to, the first stationary point is going to be the maximum. So that negative 2, 16, because negative 2 I'll hit before 0. This one should be a maximum, and this one should be a minimum. Okay, so I should know in advance what this is going to be. So let's take a look at the nature. Okay, so we'll start off at 0, 4. Then I'm looking at my second derivative. So the second derivatives was 18x plus 18. So it was 18 lots of 0 plus 18, which is 18. And the important thing here that you have to write and make sure you write is that that is greater than 0. So that means the gradient is becoming more and more and more positive, or less and less and less negative. So that happens when you have a minimum point. And if I look at the other ordinate, -2, 16, then the second derivative is going to be 18 lots of -2 plus 18, which is -18. Now you can pretty much guarantee you're right at this stage, because these should be, oops, I forgot to put my negative sign in. They should be the same numbers, just with opposite signs because of the symmetry of the curve. This is negative, so the rate of change of the gradient is negative, which means the gradient is becoming more and more negative, which means that this is a maximum. Okay, so that is the coordinates and the nature and all our working showed.